Hello, it's David. Now, it was the seminal argument back in the playgrounds of early 90s Britain, once we'd moved on from Spectrum versus Commodore 64 and all decided that the Spectrum was the winner. Were you Atari ST or Amiga? Principally the Amiga 500 here and the Atari STFM. Maybe you had an Atari STE, but chances are it was one of these two at the time. Now, perhaps you liked the faster processor that the Atari ST had, the fact that you could run your 3D games faster than the fact that it had built-in MIDI. Or perhaps you were wrong. Either way, I think what both sides could absolutely agree on is that the absolute best part about the Amiga altogether was this. That's right, its external foot warmer. Now, obviously, as much as I love my Atari ST, it doesn't have this brilliant external foot warming device. It has a built-in power supply, as evidenced by my example here. Now, this is a modern power supply, replacement power supply from Exos. It's got excellent new components. It's got a massive toroidal transformer for great linearity, but fundamentally, still floating around here, there are some pretty high voltages. Now, fine, they're all pretty well insulated and tucked away on here, but if you had one of the original supplies, something that looked like this, normally these would be sitting over here with these fins at 240 volts, and quite probably, certainly if you see on my Falcon, the switches aren't even insulated. Now, this was great, this kept your hands warm, which was lovely, but you know, it's my toes that I wanted toasty, so what I thought I'd do, given I spend a lot of my time with the lid off my machines anyway, in order to work on them, is, well, make my own external power supply for my STs and convert them all to external power.
PCBWay. Not only do they sponsor this channel, but they also make quite excellent PCBs. Unpopulated and fully built options are available. They offer CNC machining, 3D printing, sheet metal fabrication, and injection moulding too. If there's anything you're building, why not have a look at PCBWay.com, linked in down below. Whilst you're there, have a quick look at the shared projects section. You'll find quite a few of my builds there available to either download or order completely assembled. So thanks to PCBWay, and on with the video.
Now, in much the same way that the first generation of Amigas weren't actually the wedge shape that we came to know with the 500, when they were actually a desktop box, the early generation Atari ST wasn't actually this enormous wedge with the IEC connector on the back and a built-in power supply, but a much slimmer unit that we call it now the short unit, which was powered by a 7-pin DIN connector from an external power brick. So I thought, well, what better way to change the behaviour of my beloved set of STs and Falcons here than to replicate this original, such that should I ever come across an old style power supply or get myself an original ST or STM, I can simply use the same power connector. However, I then realised that this was actually a male connector. This is a 7-pin DIN in a plug format, but this would be what was mounted here at the back of the original Atari ST models. And do you know how hard it is to find a male panel mount 7-pin DIN? Well, I was unable to. But female variants are quite commonplace. So I'm going to reverse the polarity of the neutron. I'm going to reverse the polarity, and I'm going to fit a 9-pin.
5 is right out.
7-pin DIN socket on the back of my ST in the place that the IEC power connector would normally go. I'm going to rig up an external power supply, or a couple of them, probably using my Meanwell NED 50A here and my Exos third-party power supply here. and I'm going to wire up a cable with a couple of 7-pin DINs on either end. I've got myself a, I think this is a 7-core lead here that should be capable of carrying the current, and I'm going to have a safe external power supply for all of my Falcons and STs. So in order to get the connector actually in the back here, what I have tried to do was to 3D print a sort of plug arrangement. So this is what I've got. It's got a protrusion on the rear side here that fits on the inside of the IEC socket there. It takes 2 bolts to go through and 2 mounting holes, which should take the there we go, should take the 7-pin DIN, and then this sandwiches itself into the slot here by way of a backing plate, which has a couple of matching complementary pieces to allow this to slot together. There we go, and that basically sandwiches into the case. It's cut in this sort of wedge shape to allow for the shielding, that the bottom shield that I leave on the machines that have it. I never bother with the top shield. You see, that fits in there, and then this basically clips through in a complementary fashion. I just need to put some nuts on the back, and that should hold relatively securely in place. So this is actually quite a good use for my Kaiweets electric screwdriver that I was sent. I have spoken about this, that's just spinning a little bit. I have spoken about this in a previous video. I'll be honest, I haven't found it all that useful. For items that require high torque, it's not very good, and if it really does require some high torque, there's no knurling on this. It just slips and turns, and then you release the pressure on the switch. So just as an aside, it is an extraordinarily good set in terms of the number of accessories that come with it, but it's not really very much use to me day to day, I'm afraid. Now I've just nipped that up finger tight. You saw that it was spinning because I only had a little bit of light sideways pressure on the rear there. I think what I might need to do is to actually in the next revision move the screw sockets a little bit further out, because they're actually interfering with the mounting of the DIN socket here. I suspect if I undid them, put the socket in first and then screwed in, it'd be fine. But yeah, look, they actually it rocks there. Can't get those in. So slight amendment for the next revision. In the meantime, I think we can concentrate on the wiring for this DIN socket. Now the pin numbering on these 7-pin DIN sockets is a little bit weird, apparently. Seemingly it goes 6, 1, 4, 2, 5, 3, 7. Okay. So looking at the manual for the original ST, it looks like basically starting from the top left here, we've got 5 volts and 5 volts, first 2 pins. Then we've got a plus 12. Then we have a not connected, so the bottom pin is not connected. Then we have a minus 12. Then we have a ground and a final further ground. So the minus 12 is not needed by the ST or the Falcon, so I intend not to wire it up. That's also because my power supplies don't produce a minus 12. Obviously, if I had to, generally power an STM in the future, I would need to add a minus 12 generation to whatever box I come up with, or if I produce a wire for use with the Amiga, then yeah, it'll need a minus 12. So I'll probably just add a minus 12 volt module that can, pardon me, generate that off a plus 5 or a plus 12 supply. But I'm not going to worry about that for now. So primarily I'm looking at plus 5, plus 5, plus 12, ground, ground. So I think for the 5 volts in the ground, I'm going to just steal some core from a mains cable here. This should be absolutely loads. This is 0.75 square millimeter cable, which should be, I think, good enough for 5 amps, something like that. So that should be no problem. And for the 12 volt, which doesn't use anything at all, I'm just going to use this slightly thicker gauge prototype wire. That should be absolutely fine. So we only have to reach from the back of the case to the power connector, which is mid-board. So I would suggest we probably only need a length something akin to that, which to me is about 9 or 10 inches. So we'll call that 25 centimeters, 20-25 centimeters or so. And we can then just work to that scale. Only doing this for one machine initially, and then I will just repeat the process for the others. Now, memory serves, last time I did this, it was a bit of a pain. You kind of have to cut the sheathing without cutting the insulation on the actual wires in the middle, and then once you've got sort of enough of it exposed, you can start peeling it like a banana. I do have a proper tool for this somewhere. I think it's in the garage. You run basically run a razor around the outside. I may be able to. It might be short enough to actually pull directly out. There we go. And once one's out, normally, there we go. They're fairly easy because then you don't have the pressure on them anymore. You do have all this nasty white flaky material though. Right, so the big question is, will these, I'm not going to use the earth one, I'm going to have 2 blues, aren't I? I might have to use, I do have this black prototype wire as well. Maybe that's going to be the plus 12, although that's an odd colour for plus 12, isn't it? Maybe I'll just use this red, but this is solid core. I didn't really want to use the solid core stuff. I wanted to keep it flexible. Oh well, make my mind up when we get there. I want to use the mains wire on account of it being a thicker flexible gauge. And ground and plus 5, obviously, they carry all the current. Right, I'm going to need to do that twice because there's 2 5s and there's 2 grounds. Technically, this cable is probably perfectly adequate and it could do it all in one go, but you know, actually we just wire the 5s and the grounds together. But I think for the case of belt and braces, I am going to do 1 wire per pin. I'm cutting intentionally short ends on these wires because deconfliction on the DIN socket is going to be tough. So I'm pressing the wire in from the outside aspect and then heating the pin. So I'm not heating the wire directly, and then letting that whole coalesce. So it doesn't obviously matter if the 2 grounds are shorted, but I would rather they weren't. Nothing to that non-connection pin, nothing to that non-connection pin. 12 to non-connect, no. 12 to 5, no. And 5 to 5. That's the same pin. Yep, anything to shield. I wasn't planning to wire anything to shield. Excellent. Okay, so this is 2mm heat shrink, a section of 40mm, and just cut it into 3, and these run down over the wires and cover the pins like boots. There we go. Okay, and then with a healthy dose of 160-degree hot air, right down the end pipes, we should seal these nicely in place. And whilst that will never win any awards for beauty, I'm perfectly content that that will be safe and have sufficient current carrying capacity for our needs. Right, well, I don't have a plethora of these board interface connectors for the ST and the Falcon. I think I have some more for the Falcon somewhere because I ordered a batch a while ago. But these ones for the ST I've had to cannibalise. This has obviously come off an old power supply, and I use it at the moment for my long range 5-volt only supply. But I think I shall. I think this will replace that. So I'm going to steal this one from my long range supply and wire it up here. Okay, those are all soldered up. So let's get the heat shrink on again. And there we go. That's one end. Let's mount her up and see how she looks. Well, of course, here I have probably the worst 3D print filament colour to show up on camera. So if this is not at all obvious what's going on here, I do apologise. It's very difficult to get any kind of focus on it. No, I'm such a fool. I thought that would fit through the hole, forgetting that I've got this little hole in here for this. Oh, bobbins. Okay, so taking these out doesn't appear too hard. Basically, there are a couple of little tines just in here that hold it in place. You can see it's this, maybe you can see, it's this tiny raised lip here. There. And if you press that down a little bit, it's this bit, sorry, here. And if you press that down a little bit and apply a little bit of pressure, they pop out relatively easily. So that's what I'm going to do instead of resoldering everything. So first of all, I'm going to push it all the way in so I've got some space to work with. I'm going to go in with my flathead screwdriver, going to press down and then escort it out. All the way in to give me some working room. Press down, escort it out. Silly sausage. Would you look at that? It was all going so well. At least I thought it was. Well, unfortunately, I mean, that would technically work, I'm sure, because I probably only need one of these 5-volt lines, to be honest. But no, it's a do again. Okay, so take 2. This is my second attempt. I've just basically desoldered that previous effort. These are all the same wires. Still got the end piece missing. So I've just desoldered all that and resoldered a new one. Luckily, I've got like 10 of these panel mount things. So let's feed our cables through there. Now let's tighten the nuts back up. At least enough to hold them in place. Oops. And there we go. Okay, so here's how it looks from the inside. We've got the plate at the back there. Here come the cables out of here. This simply needs to zigzag like this and attach to the board like so. And I've got a nice airy space here at the back of the ST, and there's more space for me to do some development and less chance of me electrocuting myself at 240 volts. So, splendid. I just now need to do, well, you know, the entire other part, I suppose. Actually, just quickly, I've got some of this cable wrap stuff here. I know this is meant for a much thicker cable bundle. I can't find my little skinny stuff, but I think I might just put this, or try to put this on here as a little bit of strain relief, perhaps by, you know, bundling all the wires together a little bit more. Perhaps I'm less likely to do what I did before and snap them off at the plug. There we go. Let's get the other end wired up, and well, we'll check our voltages before we actually do any powering up, I think. Okay, so this is the Meanwell NED50A that I acquired off eBay. I didn't really have a use for it, so I ended up mounting it on an Atari ST power supply bracket back in an old video, which I'll link up here. And I never got around to sort of fitting it properly, but it has done a number in development machines when I want to have complete isolation there. So I think what we'll do for this particular project, that's just a 3D printed little cover, what I'll do for this particular project is disconnect all of this, and we'll basically rig up a similar set of wires going to another panel mount DIN, so that we can have a 7 to 7 DIN to work between them. And then I need to find a case in which this can live. Okay, so I misremembered. This is actually only a 6-core cable, but that's fine because we know that, I think, was it pin 2, the one at the bottom? The lowest there is always non-connected, so we don't need to worry about that. Okay, a liberal helping of flux, I think. Okay, and it doesn't really matter which particular wire I solder to which particular connection, pin, if you like, providing I keep them consistent on both ends. So, just going to get started, I think. See what I can do. I'm not convinced by that blue and that yellow there. They are incredibly close together. However, both those pins are the same. Both those pins are the same rail. So actually, I'm not going to worry about that. Okay, so this is the voltage test setup I've got here. Sharp, hurty pain voltage going into the system on this side, and we've got our V2, common, and V1 coming out here. V2 is the 12 volts, common should be ground, and V1 should be the 5. And I've got the mains rigged up to this remote switch, so I will throw it from here instead of fiddling around over there when I'm being distracted. So right, there we go. We've got our socket connected there. Let's throw the switch. Power's on. I've got a green light in the Meanwell there, so I'm going to very carefully probe common and go to V1, and we've got 5.13. okay, that's pretty good. V2 should be 11.76. that is absolutely fine. Can I get the probes in there, I wonder? I don't want to stretch the socket. So basically one of these halves should be, this is tricky, one of the halves should be ground and the other one should be 5. Am I getting any luck there? No, I don't think I'm making any contact. Nope, not making any contact there. Here's the cable we just made. I'm still live over there, so I want to be a little bit careful. Let's plug in there, and we should be able to check the voltages on this end. I'm going to use a trick that I've picked up from, I think it was Noel's Retro Lab. Pop a bit of heat shrink over one of the pins that you're intending to probe. That stops you shorting that one out. And then you can, gosh, this is going to be hard to do on camera. Then you can pay a bit more attention to the one that you're trying to connect to. I believe that says 5.135. Perfect. Switch that off. And let's get our ST up here. Okay, so we're going to do this test setup in stages. I've got the Meanwell off camera. Here's my recently constructed power lead. It's coming into the back of the ST. I'm not starting with it plugged in. We're going to probe the various voltages on the base of the cable here. So I am powering up now. Click, I heard it come on and I see a green light. So now what we should be getting is a ground on these black lines and 12 volts. Oh, it's quite difficult to probe. There we go, 11.76 on the blue line, and we should be getting a 5.1 on the red. Excellent. Okay, so power supply coming in, connected to the board. We've got a DSTB1 in the socket on account of being easier to take that out than the actual 68000. Don't have a floppy. Do have the keyboard attached because it's got a power light for one, and then it allows me to move the keyboard if everything works. And I will bring the multimeter onto the bench here, just because if it does work, well, I want to probe some of the voltage drops across that cable that we just made up. So I'm watching this green light here, and there's a green light off camera for the power supply, and here we go. I can turn it off sharpish if there's any smoke. We've got a green light, don't see any smoke, don't have any activity on the monitor though. Oh, the reset brought it up. Okay, so maybe there's a bit of a soft edge on the power, perhaps? I'm not sure, but oh yeah, no, that's not happy. Perhaps we're browning out a little bit. Okay, so no point in showing you the screen. That went for a crash screen. So let's just measure some voltages here. So what's our 5? I'll bring the camera. Yep, no, that's showing errors off screen. So what's our 5 volt line? How to get there? Come to this ground over here. 4.6. Okay, so that's actually quite a big drop. So perhaps my calculations. I don't know if you can see that. 4.634. So perhaps my calculations in terms of the current carrying capacity of that cable were off. That's a pity. Okay, so plan B, I've gone for overkill. This is actually mains cable. It's 0.75 square millimeters. It's rated, I think, for 13 amps at 100 degrees. Obviously I'm not getting that, but this is the sort of stuff that you use for lighting circuits and things like that. It's basically, I'm pretty sure, the same cable that I've got coming in here. So if this suffers the voltage drop, then we can prove that we've got a problem with the actual construction. It could be that the my DIN socket can't, carry the load for some reason. Perhaps it's, I don't know, perhaps the materials are too thin. Anyway, so we'll give this a go. So got it, just at the moment I've got it direct wired into my mean well here. That's the 5-volt line in brown. The blue is ground, and the two-tone, what's supposed to be an earth cable there, is actually just not connected at the moment. That's the 12-volt line. I've decided not to connect that just for testing purposes. Just simplifies things. The machine will boot in colour mode with without the 12-volt line. My machine won't boot in mono mode because of my VGA adapter. It draws current from the 12-volt line, but good enough to see whether we can get it to boot up. Okay, so here we go, same setup as before. We've got the colour, that's set for colour, yeah, the colour adapter in, going to my multi-sync monitor over my shoulder here. Here's our power cable coming down to the mean well. I've got it rigged up to the remote control, and we're monitoring the voltage now across that main bulk filter capacitor again. And here's obviously the power LED down here. Let's give it a try. Okay, green light, 4.9, and MUTOS is on the screen, although that's actually crashed. I think I need to do a contact cleaning job on my ROM socket. I've gone through this in a previous episode, but I think it might actually be my MMU. The ROMs here, MMUs here, I think it's definitely from this area. Just put some contact cleaner around the pins of the MMU there, and I've just reseated my ROM. There we go, just giving that a bit of a clean up around the edges there. I've shown this in a previous video, which I'll link in just up the top here. I had spent ages debugging the connections around the CPU that I changed, only to realise somewhat belatedly that the MMU is a bit dodgy. I'm pretty sure that's had a RAM expansion in there. There's normally a metal clip that these ship with, which is missing from both the PLCC chips. But I'm pretty sure that's had a RAM expansion, which sits over the top and forces the old style ones, force the pins out a little bit. So I'm pretty sure there's a dodgy contact there. There's actually a half lifted resistor somewhere around here. There we go, look, these two resistors have been lifted and then reconnected, which is a surefire sign that there was a RAM expansion going on here. And also the shifter, I don't know if you can see over here, the corner of the shifter can has been cut open. It's normally to allow a ribbon cable in for the memory expansions. I think Marpet and several others like that use that technique. And yeah, there we go. That's what I think is going on. I suspect that shifter's a bit dodgy. Right, sorry about that. I thought I was plugged in and I wasn't. So trying to get the keyboard in shot. There we go. Okay, right. So let's try that again with the contact cleaned and reseated MMU, and we'll throw the power switch. Green light, 4.9. MUTOS is on the screen, and this time it's booted to the desktop. And there we go, she has actually been running for a few minutes now, quite happily after that reseating. So yeah, I really do need to pay attention to that PLCC socket at some point. Okay, so there we go, I've added the DIN socket at the far end. The only one that I've heat shrunk here is the 12-volt line, because if ground and 5 volts short, fine, protection will kick in, won't do anything to harm the ST. If 12 volts and ground short, again, that'll kick in, but if 12 volts and 5 short and we drive 12 volts into the ST, things will go badly. So it's also the piggy in the middle, so that one's insulated. The others I shouldn't need to worry about it. Okay, so the 3D printer's been whirring away, and this is the construction I've come up with. So we've got a simple couple of self-tapping screws holding the power supply down. I think for version 2 I'll make that a little bit taller. It's not a problem with the lid that I've designed, but I think that's a bit low. and I forgot to put a hole for the switch in, so again I'll put that in there. So what I've got for now, I had to do a little bit of a repair on the side there. I think I've made these 2mm. I think I'll take up 3, the thickness of the wall. So we've got our socket here, we've installed a switch here, and I've put a 20mm gland in here to tighten that up. It's just because I happen to have those laying around. That is providing strain relief on there. This is the same mains cable that we have. This should hopefully plug in and out. Oops, I mounted it upside down. Yeah, it's needing a little bit of flex there. I think, yeah, version 2 is going to have thicker walls, no trouble. But for now, this should be okay for testing. And here's a lid that I've printed. This has got the vents in it. I think version 2 again, I'll put some vents down the side. And we will mount this here in like this. Let's get it screwed up, and we will have a little bit of a look at it. Okay, so the trick I use when putting self-tappers into 3D printed material like this is that I'll measure the overall thread width of the self-tapping screw that I intend to use. I think this one was about 4mm, and I make these the holes in the lid here just about 4mm. So there might be a little bit of friction on the side, but they should basically, there's a little bit of friction there, but they should basically just drift through without any notable resistance. Screw them in until they are just protruding from the end, and that's how we'll do our alignment. In terms of the receiving threads on the 3D printed case here, what I do is I print these. So again, I measure the shaft. So the inner shaft here is about 2.5mm. Say the thread is about 4, and the head is about 7. So what I'll do is I will just sit those. So print that at somewhere between the shaft width and the thread width. So I think these are 3mm. And I'll sit that in there, and I'll bring in a soldering iron. So it will hold that in position like that. Bring in a soldering iron at 350 in my case. Sit that in there. The whole thing will heat up. Won't take long. And then once it's warm, you basically work it down into the plastic. I've already done this one, so I don't want to do the same thing again. But you work it down into the plastic, and that's how you. Is that hot enough to pick up? Cool enough to pick up? Yep. And that's how it taps its thread. Then you just wind it back out, and you try and put it back in the same thread. And that way, there we go. You get a nicely threaded insert, and you shouldn't crack anything. There we go. Yeah, I have got a version 2 designed with the switch there and a bit of extra support, slightly thicker walls, and some vents down the side. But unfortunately, it had a bit of a crack all the way around it on the printer, and I'm just going around cementing that back together to see whether that's salvageable or whether I need to make another print. So I've decided not to delay the project any further, and we'll use version 1 for now, and I shall transplant them at a later date. And what I also intend to do is to build a second version that will take my Exos power supply. Here's my Exos power supply, still in the bracket. It's an absolute beast, and this runs nice and cool as well. So this will fit probably not into the same. I'd have to measure the offsets, I doubt they're the same, but probably not into exactly the same case, but basically into the same design but with different standoffs. And that will give me one supply for in the shed and one supply for in the house. Okay, so perhaps, yes, a sledgehammer to crack a nut, and maybe not everything went entirely according to plan first time. Still don't know what was wrong with that original cable, but there we go. A problem that I have solved, and all I need to do now is to modify the internals for my other machines, and I'll have a nice, safe external supply for all of my development needs. Thank you so much for watching. See you in the next video.